ORFEUS is a project that comes from quite a long line of partly EC funded projects running from the EC Framework 5 through to Framework 7. We started in 2002 with a project called GIGA. GIGA was a general project looking at the feasible techniques that were available to improve the performance of radar for ground probing purposes. Out of that came the requirement for a radar that could be mounted on the tip of a drill string for a horizontal directional drilling machine. The technical problems that we foresaw with that is that the radar had to be quite small. The environment that it had to stand was quite extreme. Nonetheless, we thought that it might be feasible to do that. So in Framework 6, which we started in 2006, we defined a project which was looked at, among other things, putting a radar onto the tip of a drill string of a horizontal directional drilling machine. And we aimed to do some practical work in that area to test the feasibility. During the project we found that the feasibility in fact was quite good, and we thought that we could achieve a detection range of about half a metre, which was reasonable enough to be able to provide a good performance in order to be able to guide the drill and to be able to avoid obstacles as they occurred in the drilling path. We don't want to hit obstacles in the drilling path because they cause enormous damage and they're a safety hazard as well. So we got to the end of ORFEUS 1 in 2010, and then we started to think about what would be the next stage for Framework 7, and we decided that instead of doing a general radar project we would concentrate on drill string radar, and we wrote a proposal for ORFEUS 2. Now of course, when you start an EC project, one of the important things that you have to do is define an acronym for the project. And that takes up quite a lot of time at the start of a project, and we had a little competition of how we would frame the acronym. And the acronym of ORFEUS actually stands for Operational Radar for Every Drill String Under the Street. A little bit contrived, but if you pick out some of the capital letters in that phrase, you come up with ORFEUS. So we called the project ORFEUS, and we collaborated with 11 partners distributed throughout the EC, and there are 6 European countries involved in the project. There's Italian people, there's people from France, Germany, Slovenia, Greece and Ireland. That's 7 countries if I've got them all right, and we're looking at several methods of implementing the radar, from the radar system itself, which has to be mounted, as I said, on the drill tip, and we're looking at the electromagnetic aspects and the environmental aspects of doing that. Then when we've collected the radar data, in order for it to be any use, it has to be transmitted to the surface in real time. Quite a lot of data, so we have to do that at a very fast rate. We have to transmit it along a drill string, which is perhaps 100 meters in diameter, in length, maybe 200 meters in length. The drill string is filled with a fluid called bentonite, which mainly consists of water and also a clay slurry. So that makes a very poor transmission line. So we're looking at spread spectrum techniques for developing the system to be able to get the data in real time from the drill string tip where it's collected up to the cab at the surface where the operator sits, so that he can take decisions based upon what the radar says, mainly to avoid hitting obstacles in the drill path, but also to make sure that the drill string is guided so that it can have a minimum clearance around the drill string, so that in the second phase of the operation, where the pipe is drawn in from the other end of the operation, that is a larger diameter than the pilot bore that went in originally. We have to make sure that there's sufficient clearance around that drill string to be able to guarantee that when the larger pipe comes in, there is sufficient clearance from other buried pipes and cables so that we don't get an unacceptable interference between the pipe that's coming in and the pipes that are there. So that's the purpose of the project. It's a 3-year project, and at the end of it what we aim to come up with is an operational system that will stand up to the environment, fulfill the specification, and be able to be used in operational situations. The objective being to extend the range of operational situations where horizontal directional drilling can be deployed. ORFEUS Technology is acting as the project coordinator. I am the project coordinator. We carry out the management functions and we look after the finances of the project, but also we have a technical role within the project, and our particularly technical niche in the project is to develop the communications link that enables the data to be transmitted from the drill string head along the drill string and up to the operator who is sitting in a cab above ground, who needs the information to take operational decisions about the guidance of the drill string.
One of the areas that has taken us a lot of effort in development in the ORFEUS project has been the communication system and the system that connects down the drill rods. The system has to take power from the top, where the drill rig is, down to the drill head. The difficulty is that the connectors have to be mated and disconnected when they're wet. So this has taken a lot of development work because we have to have both data and power. The development work of the connectors themselves has been done by Tractor Technic, and we at ORFEUS have worked on the communication system using spread spectrum technology. This allows us to get real-time fast data down to the drill at the same time as transmitting power. The difficulty is always that you're working with an imperfect system where the connection system is working in water and mud and is being connected and then disconnected automatically. So there's little chance of intervention to adjust anything. It has to work first time as the connectors are put together. The critical issue is to give real-time data from the drill head back up to the drill operator throughout the operation as the drill rods are added. And during, say, a 100-meter drill operation, there will be about 30 to 35 changes of rods. So there are a lot of connectors involved, a lot of interconnections, and a lot of distance down the drill string to attenuate the signals. Hence the fact that it's become quite a difficult and challenging development for us to do with Tractor Technic.
My name is Guido Manacorda and I work for IDS, Ingegneria dei Sistemi, which is an Italian company dealing with radar and specifically with ground penetrating radar since 20 years now. We joined ORFEUS with the specific task of designing a new radar for this application. And in this application, the use of radar is important because you are basically blind when digging into the ground. Can you imagine driving your car without looking ahead? That's what is happening with directional drilling machine. So we put a radar there just to give the possibility to detect objects and obstacles around the drilling head. And in this framework, IDS was designing the antenna, which is a critical task because of the limited space on board the directional drilling machine, the microwave source and receiver, the controller, and the data processing software. And the software has also required a lot of effort because it's basically extremely different than the software used for ground penetrating radar when used on the surface. The machine is rotating, which is different than the common way of surveying with surface penetrating radar, and we had to add a fully automatic detection of targets in order to produce a warning when an obstacle is close to the drilling head and avoid hitting or making damages. So now the design job has been completed and we are looking forward to starting with the trial period, and hopefully we will succeed in having a commercial viable equipment within the end of this year. And this, in our view, is a clear step ahead in the technology, because standard surface radar have a limitation in penetration range. So when used from the surface, you are not capable to detect very deep pipe. So we put a radar on the tool, because the tool will go closer to that targets, and actually we put the sensing machine where it's actually needed.
Well, one of the things about the ORFEUS project, as you're aware, is the fact that the time has come to pass where we look at the infrastructure and utilities which are now under the ground in many of our cities and towns, and it's become a far more complex picture. And so the ORFEUS project has been designed around the development of new technology which will aid contractors that are involved in that industry. But the project itself, funded through the European Commission Framework Programme 7, has quite a tight timeline with a range of deadlines and is quite ambitious, and the technological challenges and scientific challenges mean that this complex project needs to be managed very efficiently and effectively. The role of EURAM within the project is to support that project management aspect, to make sure that the deliverables are achieved on time and that we disseminate and exploit the results of the project, because ORFEUS is quite an interesting project in terms of the ultimate outcome. One of the aspects for many of the European programmes is the effective exploitation, and this project is actually going to lead to a product which can be fully exploited and commercially utilised by a range of potential clients to the partners within the project. So EURAM is intricately engaged in making sure that this project runs smoothly, that the deliverables are achieved, and that actually we are well positioned to produce a product which meets the customer requirements and can actually enter the marketplace and have benefit. Well, EURAM, as project manager, we work with a range of different consortia and a range of EC funded projects. With respect to ORFEUS, this is a very specialised but multidisciplinary team which has come together from a range of European member states. And what is interesting is that we have both the technology developers and we also have the industry partners that are actually going to be responsible for exploiting and developing that technology and delivering it as a new product to their customers. And the aspect and dimensional side to this consortium means that actually all of the components to achieve success are here. The consortium, comprising a relatively small number of partners, has all of the capabilities and expertise to take the product from initial technology development, has the capability to overcome technical and scientific barriers, and actually then through the industry partners both deliver to their clients and importantly disseminate the project results and exploit the project results to the wider community. And in terms of market, this is not just about a European market, this is a truly global market opportunity. And as such, the value add from this product is not just raising the profile of the industry partners, it's not just about providing a new product to a niche market. This is a global opportunity which will actually help place European technology development in trenchless drilling at the forefront of the global marketplace. And that's really an amazing achievement for what is a project which is going to be completed within quite a short time frame. And that demonstrates both the capability the motivation and the interest and participation of those partners to work very effectively and in a true collaborative way to achieve a really clear and value-add product at the end of this project.
And GDF Suez invests money on research projects concerning buried assets location tools, so as to be able to detect and locate any part of its network anywhere. The ORFEUS radar improves the safety of our gas distribution networks and guarantees the supply of our customers with a decreased amount of accidents. Trenchless technologies are currently mainly used in France to bypass difficult obstacles such as rivers or railways, and it's little used in urban areas where there are dense arrangements of buried pipes. In urban areas, a reliable and efficient detection tool would considerably increase the use of HDD techniques. GDF Suez is involved in the introduction of the new prototype for field testing once operational. The buried assets location radar will be tested in the company's gas research center in Saint-Denis in France, one of the biggest gas research centers in the world and unique for such purposes.
Tractotechnik is a technology leader in the Nordic world market. From Germany, we provide trenchless pipelaying solutions through a worldwide service and distribution network. Our role in ORFEUS is the verification of customer needs in field demonstration. Another key element is the development of a drill rod with integrated conductor to transfer electrical power and data signals. We are also involved in exploitation, planning and standardization. In September 2014, we will run the first tests in our own test field in Lennestadt. Further trials with top contractors will follow until mid-2050. These are Leonhard Weiss in southern Germany, our partners in ORFEUS, Gaz de France Suez in France, and Wilkograd in Slovenia. We will particularly lay focus on working in varying soil conditions. The main obstacle to increased use of horizontal directional drilling is a lack of effective location technology. Impending liabilities deter potential users from dealing with HDD. The borehead radar will improve the quality of the HD work. Consequently, this increases the safety of the installation immensely. We firmly believe that the enormous cost-saving potential of this drilling technology, now combined with a reliable borehead radar, will increase the market for HDD users.
I am director of Wilkograd. We are a European company for construction and reconstruction of pipelines using Nordic technologies. We drill up. We are participate in field demonstration of the ORFEUS radar. We will do full drilling test with this drill rigs, drill strings, communication modules, radio electronics and antenna, in order to test the system performance and to detect correct faults. In my opinion, there will be benefits from the ORFEUS radar in installation of telecom cables, water mains, gas networks, sewage lines, also river streets and railway crossings of other nature or artificial substance and so on. The drilling procedure using HDD technology is economic and quick, of course, does not impact the environment during and after implementation. The first of all, it is, let's say, the insurance companies who is involved in that business have so less amount of the problems with the pay of the insurance when we don't make some mistake or we don't destroy some infrastructures. Of course, also for the owners of the infrastructures, because they looking for infrastructures itself, and they are care about and they must to work carefully with that infrastructure like water lines or something. And when we do something or when we damage the infrastructure, they have a lot of problems. And the last one is operators of the drilling rigs. What's the key? The operators which drilling with the HDD machines have the problems because works in a lot of stress because doesn't know what is officially under the ground, and with the radar they can see.
I think the important thing to remember about ORFEUS is that more than 50% of the population in the world now live in urban areas. And in those areas they receive electricity, they use gas, they have telephone, broadband services, they have water to use, they have drainage. We manage the traffic through traffic signals and through CCTV. All those services in urban areas are delivered by pipes and cables, most of which we never see because they're buried under the ground. That means we need to mend them sometimes and we need to find them. And in some areas, there's not much room left under the street because there are so many services. So we need technologies like ORFEUS to help us manage better what we have under the ground. Mapping the Underworld started in 2006. I managed the workshop in the UK that developed the project. The aim being to develop a new generation of technologies to find buried assets, particularly those small ones close to the surface and plastic ones, which can be difficult to find with existing technologies. Mapping the Underworld has moved in now into a second phase, into a project called Assessing the Underworld, where the researchers are hoping that using mapping the underworld technologies can be used to actually identify the condition of the assets as well as the location. This is still a long-term piece of research and there's a long way to go. But ORFEUS fits within the whole spectrum of technologies that need to be used to find, replace and repair assets under the ground. In ORFEUS, I'm managing the work package to develop a standard, to review existing standards within the sector to which this technology might apply, and potentially to develop a new standard. So we're working with DIN in Germany, the German Standards Institute, to develop a PAS, that's a publicly acceptable standard for use of this GPR technology on a drill head for trenchless technology. The real target group is the users of technology, those who want to do things faster, more efficiently. Part of the problem with finding buried assets is that we normally have to dig up the road. That doesn't sound difficult technically, but what it does do is create problems with traffic, because normally part of the road has to be closed, so there is restricted traffic flow, hence there is congestion, and that upsets the travelling public. We can use technologies like ORFEUS, then we maybe need to close the road less, so we have less congestion, so all these savings can be made.
Exergia works on the promotion of the ORFEUS drill tip radar in order to demonstrate its added value to the horizontal directional drilling market as well as the utilities. This is accomplished through workshops, exhibitions, tutorials, films, publication material and other promotion activities. It is really interesting to introduce such an innovative product to the HDD market, as it has many benefits, ranging from environmental and economic up to health and safety. The ORFEUS drill tip radar takes the guesswork out of the horizontal directional drilling. It increases the quality and safety of work through minimization of damages and accidents, and it also ensures a greater acceptance of HDD technologies.
Florence Engineering is involved in RTD activities concerning the borehead radar prototype and data processing, and also in demonstration activities and analysis of results. Particularly, we have developed a special sensor to measure the orientation of the borehead whilst it is rotating, and this information is very important for combining radar images and for detecting obstacles. The horizontal directional drilling with the detection capability supplied by radar is surely a step ahead for the innovation of the process to install utilities on the street. As a matter of fact, it will provide operators and the general public with economic, with environmental and safety benefits by reducing damages of infrastructures through the trenchless technologies and through the detection of obstacles approaching the drilling path. About environmental benefits, you have to know that the carbon footprint of a traditional installation of 200-meter long pipeline with the standard open trench technique, taking into account the emission at site for material production, transport and storage, is more than 8 times greater than in case of horizontal directional drilling, and HDD can take further advantages of radar.
Well, currently at the moment, roads authorities would not be very happy with the use of horizontal directional drilling in an urban environment, because when a horizontal directional drill is used, it can do a lot of damage to service connections and pipes, etc. And there's no way of telling that. So, although the service can be put in by the particular utility that's using it, such as a gas company or even a water company, it doesn't mean that the roads authority knows what damage has been done. So, from the point of view of a roads authority, any roads authority, it means that if you can clearly see from a data log or from images of what the drill is doing at the time, that it is not hitting any of the services that are already in the ground, that's a major advantage. And it means that you're not chasing the company who's done the drilling for damages done. That's a great advantage. From a traffic point of view, it means that the job can be done quicker, with less disruption, and possibly it means that less junctions are affected. And when you're running a city and when you're trying to make sure that traffic flows smoothly, junctions are the key. And if horizontal directional drilling could be used with certainty that there's no damage to other services, then that would be a major advantage to all concerned. Now that's also from the contractor's point of view, because it would be cheaper for the contractor. It's also a major advantage for the utility, because the utility could plan with a degree of certainty how long it would take to do their services. So all in all, it gives you an opportunity to use it, a proven technology, but in a way that all of the stakeholders can sign up to it. Because at the moment, speaking from a roads authority point of view, I wouldn't be happy with horizontal directional drilling in the city. But if it's attached to an image that shows that it hasn't done any damage, and which can be generated by ground penetrating radar attached to the drill head, and if the data analytics are all there to prove that it hasn't hit anything, there is the real possibility of safety advantages. Because if the driver or the operator of the horizontal directional drill, the HDD, can see something before he hits it, that means that he can stop the horizontal directional drill and therefore not hit the service. Now, some of these services, if you hit them, can be very dangerous. Gas, water under pressure, and especially electricity. The other advantage that it has is that if a route can be found, that means that you don't have to hand dig around a lot of these services. It means that it takes the general operative, the man with a shovel in a hole in the ground, out of the equation, and that would hopefully add to the safety record of the utilities companies placing their materials in the ground.
The ORFEUS radar increases the safety margins of the horizontal directional drilling technique by allowing an accurate knowledge of underground utility assets and other obstructions in the drill path. The ORFEUS radar decreases roadworks, facilitates traffic and ensures public safety by avoiding accidents from unsafe trenchless activities such as gas leaks and explosions. Significant injuries and/or casualties caused by gas or electricity lines being damaged during excavations are reported every year. In the UK, there has been one death in each of the 10 last years as a result of street workers damaging electricity cables when excavating to repair other burying assets.